During Operation Return of the Condor, conducted at Fort Hood, Texas, on August 27, 2025, the U.S. Army revealed a new stage in its adaptation to modern threats by integrating counter-drone tactics directly into armored maneuvers. The exercise was not just a display of combined arms training but a deliberate attempt to redefine how mechanized forces can survive and operate in a battlespace dominated by small unmanned aerial systems. Instead of positioning drones as a peripheral nuisance or leaving the responsibility for countering them exclusively to air defense units, the Army tested a model where armored vehicles themselves became central to the fight against hostile aerial platforms. At the heart of the exercise were M2 Bradley Infantry Fighting Vehicles, traditionally known for transporting infantry, providing fire support, and operating as resilient armored assets. In Return of the Condor, the Bradleys were equipped and tested as mobile anti-drone platforms, linking electronic warfare suites, detection nodes, and jamming systems into their combat roles. As the vehicles maneuvered across varied terrain, small unmanned aircraft simulated reconnaissance and strike missions against them, forcing crews to respond with real-time countermeasures while maintaining their offensive and defensive tasks on the ground. This dual role emphasized that in future combat, survival depends not only on armor and firepower but also on the ability to detect, disrupt, and neutralize drone surveillance. The exercise focused on how drones affect tactical decisions when armored columns are moving or engaging in combat. Drone observation forces commanders to change formations, adapt speed, and alter communications to avoid becoming predictable targets. To simulate this, the Army integrated radio frequency detection, passive radar sensing, and jamming capabilities into the maneuver elements rather than leaving them isolated with dedicated air defense. Each detection system was tied into digital command networks, allowing for rapid exchange of information and coordinated response. As Bradleys advanced, they became both combat vehicles and nodes in a distributed defense web, creating a moving shield against overhead threats. One of the most notable innovations tested during the operation was the use of multi-sensor fusion algorithms. These tools brought together radio emissions, thermal signatures, and visual data to generate a single threat picture for vehicle crews. In practice, this meant that soldiers could not only detect a drone but also classify it, prioritize its danger, and choose an appropriate response within seconds. The ability to combine multiple data streams while on the move marks a departure from the slower, more centralized decision-making of previous doctrines. By pushing analysis and decision power down to the vehicle level, the Army seeks to ensure that small units can handle drone threats independently, without waiting for external commands. Return of the Condor also validated how counter-drone measures perform in high-mobility conditions. During assaults, flanking movements, and defensive postures, Bradleys maneuvered with full awareness of drone activity overhead. Units adjusted spacing and formations to reduce their electromagnetic signatures, while electronic warfare assets created protective envelopes to block drone communications and targeting systems. Importantly, these measures were employed without revealing excessive electronic emissions of their own, reflecting the fine balance required in a contested electromagnetic spectrum. The synchronization of armored maneuvers with electronic warfare effects is now viewed as a critical enabler of survivability in large-scale operations. The exercise drew heavily from battlefield experiences in Ukraine, where commercial drones and military-grade UAVs have rewritten the rules of ground combat. Armored columns there have repeatedly been exposed and destroyed by precision artillery fire guided by drones. These lessons underscored the vulnerability of even well-armored units when confronted with persistent overhead surveillance. At Fort Hood, the U.S. Army confronted this reality by training crews to counter real-time drone detection, to break the kill chain before artillery or loitering munitions could be directed against them. Radar avoidance techniques, strict signal discipline, and even active deception tactics were drilled, ensuring that mechanized units learned how to reduce their visibility to airborne sensors. Another dimension of the training involved replicating the electronic warfare conditions common in Ukraine, where both sides employ jamming, spoofing, and electronic attacks against communications and navigation systems. By placing Bradley crews in environments where GPS signals were degraded or radios became unreliable, the Army tested the resilience of its formations under conditions of electronic denial. This approach ensured that soldiers could continue to operate effectively when their digital tools failed or became compromised, preparing them for the reality of modern conflicts where no system can be assumed to function without interference. Perhaps the most significant aspect of Return of the Condor was its demonstration that counter-drone systems must no longer be treated as add-ons or temporary fixes. Instead, they need to be designed as integral elements of combat vehicles and formations. The modular sensors and jamming tools tested on the Bradleys point toward a future where armored units are equipped with scalable counter-UAS packages as standard equipment. This vision aligns with ongoing development of the optionally manned fighting vehicle, the planned replacement for the Bradley. Lessons from the exercise are expected to directly influence how the new vehicle integrates sensors, computing power, and data links to make counter-drone functions seamless with traditional armored warfare tasks. By forcing units to fight against active drone threats during live maneuvers, the Army confirmed that counter-drone operations can be conducted without slowing operational tempo. Soldiers learn to detect and react while in motion, to balance their ground missions with the need to address aerial surveillance, and to make rapid tactical decisions in environments where every second mattered. The goal was not just detection but integration, ensuring that every armored movement also contributed to the overall defense against drones. This approach turns each vehicle into part of a collective shield, one that moves and fights with the formation rather than remaining static. The broader implications of Return of the Condor reach into doctrine, training, and technology development. On the doctrinal side, it establishes that drone defense is inseparable from maneuver and firepower, and that every unit must carry responsibility for protecting itself. In training, it reinforces the need to expose crews to contested electromagnetic conditions and to teach them how to maintain discipline under constant observation. Technologically, it validates investments in onboard computing, sensor fusion, and distributed networks that allow units to share threat information instantly. As near-peer competition grows and adversaries expand their use of drone swarms, loitering munitions, and autonomous aerial systems, the importance of what was tested at Fort Hood cannot be overstated. Return of the Condor represented a rehearsal for conflicts where the speed of drone targeting cycles far exceeds traditional kill chains, and where armored survivability depends on combining steel protection with digital awareness. The exercise did more than showcase counter-drone gadgets, it defined how the Army intends to weave detection, electronic warfare, and maneuver into a single fabric of combat power. In the end, Operation Return of the Condor illustrated that the battlefield of the future will be shaped as much by invisible signals and algorithms as by armor and firepower. By transforming the Bradley into both a fighting vehicle and a drone defense hub, the U.S. Army signaled its recognition that counter-UAS capabilities must be integral to every element of ground combat. This shift ensures that armored forces can not only withstand traditional threats but also prevail in an era where drones hover over every advance, and where the ability to outthink and outpace digital enemies may prove just as decisive as firepower itself.